Hi and welcome to today's video. In this video I'm going to be talking about some of the basic math that comes with chemistry, and in particular I'm going to be talking about accuracy and precision, rounding and significant figures. This is something that I've found in my experience students actually do very poorly in and struggle to understand. This is particularly relevant for any kind of quantitative analysis, but you can also use this anytime you have to do any kind of calculation, for example, energy change calculations, mole calculations, all sorts of things like that. All of those are going to use these ideas of accuracy and precision and rounding and significant figures. Okay, so first off, what are we talking about when we talk about accuracy and precision? Well, accuracy is all about how close your answer is to what the correct answer should be. Okay, and in chemistry, we want accuracy. Nobody's interested in an inaccurate answer. If it's not right, it's not right. And precision, when you take multiple measurements, for example, when you're doing a titration or an experiment and you do something several times, precision is about how close those measurements are to each other. So just to give you a bit of a graphic on what I'm talking about here. Okay, if we look at these four dartboards, the top left-hand corner one, you can see is not accurate because the dots aren't anywhere close to the bullseye. Well, one of them is, but that's all. And it's not precise. They're not clustered close together. The one in the top right-hand corner is very precise. You can see that they're all clustered in one spot, but it is not accurate. They're nowhere near the bullseye. Bottom left, we have accuracy. If you took the average of those, it's going to come in pretty close on your bullseye, but they're not precise. Okay, and the final one is accurate and precise. Now, if you're getting low accuracy and high precision, so the top right-hand corner, that would imply that there is an issue with your experimental technique. You're doing something systematically that is not correct. Perhaps you're reading your burette consistently wrong, or your pipette consistently wrong, or your thermometer consistently wrong. So it's usually some sort of a consistent error. Or it could be that your equipment is out in some way, so it's not calibrated correctly. Perhaps your balance is incorrectly calibrated, and so it's consistently giving you the wrong answer. So you're doing everything correct except for one point in that measurement where you're making or where a consistent error is occurring. If you're getting high accuracy and low precision, that would imply that you're sloppy with your technique. Okay, so perhaps you're not always accurately picking the end point of your titration. All your things are done pretty good, but all your reading of your burette is just like it's a little bit off every time, but you're doing everything pretty good. What you're targeting is high accuracy, high precision. That's what we want to see every time. Okay, so the next thing I want to talk about, when we talk about measurements and we're reporting measurements, what you're reporting has some degree of accuracy. And if you understand about rounding, remember with rounding, if the number is, last digit is 5, 6, 7, 8, or 9, you round up. And if the last digit is 0, 1, 2, 3, or 4, you round down. Okay? So when you see an answer reported, say it's 10 meters. If I see a measurement that says 10 meters, what that tells me is actually that measurement is somewhere between 9.5 and 10.4 meters, because both of those will round to 10 meters. If I've actually measured it more, so if I've measured with a meter ruler, let's say I'm measuring the length of the room and I get my meter ruler out and I've got 1, 2, 3, 4, and I've got 10 meters in the room. Really, yeah, it's about 10 meters. It's somewhere between 9.5 and 10.4. Okay, if I've got a very accurate tape measure out that measures to the nearest centimetre, then I could say, if it came in at exactly 10 metres to the nearest centimetre, then I could write that measurement as 10.00 metres, which really means that it's within about, well, it's between 9.995 metres or about half a centimetre short, to 10.004 metres. Okay, so now we're getting down to the degree of accuracy. We've measured it more accurately so we can report the answer more accurately. If you've measured to the nearest centimetre, you have to report to that degree of accuracy. If you've measured to the nearest metre, you report to that degree of accuracy. If you've measured to the nearest micrometre, which is like a millionth of a metre, then you would report to that degree of accuracy. Okay, so you must be aware. If I've measured to the nearest kilometre, if I've measured the distance between Blenheim and Nelson, and it's about 100 kilometres, then I can't say with any accuracy that that's actually 100,000 metres, because it's not 100,000 metres. It's, you know, somewhere around about between 100 and, it's in kilometres, right? So be accurate with your reporting, and if you're converting things, be aware of how accurate your measurement is. Now, one way to do that is to use standard form. Hang on, first off we'll look at significant figures. Yep. So significant figures is a way of measuring accuracy effectively. Okay, and it's the number of digits after the first non-zero one. Okay, so I've got some examples there, and most of those are pretty straightforward. 27.1, you can see it's got 3 sig figs. 100.42, you can count it's got 5. The next one down, 0.00011, has 2 sig figs because we ignore those first zeros. All the zeros on the left we can ignore because they're just placeholders. But if you look at the bottom example, 0.0001100, the last 2 zeros are actually significant because they're representing a degree of accuracy. They're not placeholders, they're showing accuracy. Now, one way to show that is by turning it into standard form. Okay, now standard form, if you're not familiar with it, is a way of writing really large or really small numbers. So it's simply working out factors of 10. Okay, so 100.42 is really 1.0042 times 10 to the power of 2. 10 to the power of 2 is 100, right? So simply done, if you look at that 100.42, if you take the decimal place, you can move it back 2 points, and that gets you to the 100. 1.0042. So it's gone back 2 places, so it's 10 to the power of 2. 0.00011, if we take that decimal place, we're going to move it 1, 2, 3, 4 times to get it between the 2 ones. So 10 to the minus 4, because it's a number that's smaller than 1. And when you look at those numbers written in standard form, it's really easy to see how many significant figures they are, right? 5, 2, and 4. Very obvious. Now, the only tricky one to consider, both with standard form and with significant figures, is when you see round numbers. If I say a kilometre is 1,000 metres, is that 1,000 4 significant figures or 1 significant figure? And it comes down to how accurately it's measured. That's why it becomes really useful when you put it into standard form. Because if I have 1,000 metres, if I say that's 1 times 10 to the power of 3, then that would imply that that's 1 significant figure. If I say 1.000 times 10 to the power of 3, then that's 4 significant figures. So one's measured to the nearest metre and one's measured to the nearest kilometre in terms of accuracy. Now, little piece of advice on your calculator. If you've got a scientific calculator, which I would expect everybody to have, down next to the equal sign is a button that's labelled either EXP or 10 to the X. And that is the way to put standard form numbers into your calculator. So if you wanted to do a calculation that involved 100.42 times 10 to the power of 2, and you didn't want to type it all in or try and convert it and hope you got it right, on your calculator you would just go 1.0042 EXP 2. And that will get you that same number. I'm going to try it, make sure you can do it. Okay, now, where does all this come into play? Well, it comes into play when we come to do rounding, and particularly with significant figures. So when you do a calculation, you know, you've measured the length of the room and you've measured the width of the room, and then you want to multiply them together to work out the area of the room. Your calculator will just spit out however many numbers it comes up with, but that doesn't tell you how accurate your measurement really is. So if you're multiplying or dividing two numbers together, you should round your answer to the least number of significant figures in your measurements. I'll show you some examples in a minute. Adding or subtracting is easier. If you're adding or subtracting, you should round to the least number of decimal places. Okay, but I'm not really going to worry about that because most chemistry doesn't involve a lot of adding and subtracting. It involves a lot of multiplying and dividing. So let's have a couple of examples of those. Okay, so here's an example. We've measured a room. We've measured it to the nearest centimetre. All right, we've got 27.33 metres in one direction. That's 27 metres and 33 centimetres if you're not happy converting units, and I might just talk about that in a moment. In one dimension, and 51.75 metres in the other dimension. When you multiply them together, it gives you this wonderful answer. But if we look at that data, those two measurements are both in metres. Okay, our answer's in metres squared. And we've got 4 significant figures in each of those values. That means our answer should be rounded to 4 significant figures. So really, 1,414 square metres should be our answer. That is the degree of accuracy that we can claim with that measurement. Okay? Here's another example. Let's say we're measuring some speed. Now, we know the distance that's been travelled very, very accurately, 17.6332 metres. And we've measured the time on a stopwatch and we've got 2.2 seconds. Pop those numbers into a calculator and you get something quite ridiculous that actually is a recurring answer. So it's 8.015, 0909, 09, 09, 09, 09, 09, 09, etc. We can't report that. The time is only accurate to 2 significant figures. So our answer can only be accurate to 2 significant figures. Sometimes this feels really weird. It feels like you're taking away accuracy, but what you're actually doing is being honest in reporting your answer. Okay, it just doesn't feel like it. And here's your final example. Let's say a cyclist is travelling at 15.7 kilometres per hour and they're cycling for 3 hours. And if you bung those numbers into your calculator, you will get a distance travelled of 47.1 kilometres. But that 3 hours is only accurate to 1 significant figure. That means realistically it's actually somewhere between 2.5 and 3.4 hours. We haven't been given any more detail than that. So it's about 3 hours. So we can't really claim that they've travelled 47 kilometres and 100 metres in that time. If they travelled exactly 3 hours, we could, but we don't know that they've travelled exactly 3 hours because we haven't been given that level of accuracy. So we have to round it to the level of accuracy that we have, which is 1 significant figure. So in 3 hours, they've travelled 50 kilometres, approximately, because it's only approximately 3 hours, really. 1 significant figure is never an accurate result. Okay, so I know that this feels a bit weird to almost take away accuracy, but actually what you're doing is being honest. Now, one little proviso. If you are doing multi-step calculations, so you've got to calculate this, and you've got to calculate that, then you've got to calculate something else, and you're using your answers in subsequent steps, do not, I cannot say this strenuously enough, do not round before the last step. Do not clear the number off your calculator and type it back in again. Use the answer button on your calculator and use the complete answer in each subsequent step. Okay, I'll give you some examples of that in later videos, but rounding too early also introduces inaccuracies and errors into your math. Okay, there are lots of problems out there where you can practice things like rounding. Talk to your math teacher as well. It is an incredibly important skill, and if you're taking physics, even more so. I will see you in my next video. Thanks for watching.